Hello, good evening. Welcome to the Bay Area Spark Meetup. My name is Jules Damji. I'm the Spark community evangelist at Databricks. I'm delighted to see this big community over here. How many of you are data scientists here? Only a few hands? Come on, man. Guys, how many of you are data scientists? Let me ask, how many of you are data scientists here?
They are shy.
Okay, well, you're actually at a good meetup. First and foremost, I really want to thank and acknowledge Salesforce for hosting us and for providing all the beers and making us drunk and feeding us good food. So give them a big hand, please.
I'm the first time here. I get lost in the shopping mall. I can't understand they are in the shopping mall.
Well, it's a good shopping mall, believe me. In particular, I want to call out Alexei Rus, my colleague that I worked with a while back. He has been a Spark advocate and evangelist for a long time. Also, Sean Felden and all the other Salesforce people who actually help us organize this meetup. So give them a big hand, guys. And a couple of announcements. If you haven't found the toilets and the washrooms or the bathrooms, whatever you want to call them, out on the left, take a left. You'll find them over there. We also have another meetup coming up in a month called Structured Streaming. We'll be hosting it at Bloomberg, so follow us on Twitter. You'll actually find out. This is the good stuff that we are actually introducing Spark 2.0, so this will be a good for those of you actually interested in writing continuous application end-to-end using the new structured APIs. Make sure you attend that. And without any further ado, I'm going to have Alex come and make some announcements and then introduce our first speaker.
Thank you very much, Jules. Thanks again, everyone, for coming. We're happy to be hosting another Spark Meetup. We have two great presentations today. I want to thank again people who organized that, Sean and Amanda in the back. Thank you very much. And also, I want to mention, that not like many other companies we're hiring, we're actively growing and hiring. We have lots of exciting opportunities, especially around data engineering, machine learning, back-end engineering, front-end. We have a few, Salesforce people here. We have a bunch of recruiters also. So please come talk to us if you're interested in exploring opportunities. Without further ado, we have a first great talk that Donald is going to be doing. Donald is one of the co-founders of PredictionIO, and he's going to basically tell us all about that.
Thank you, Alexei. Good evening, everyone. My name is Donald Szeto. I'm a tech lead at Salesforce and also the first Git committer of PredictionIO. Salesforce has generously donated PredictionIO to this Apache Software Foundation. This evening, I'm going to give you an introduction of PredictionIO. So this talk is intended for people who is not familiar with PredictionIO. In this talk, I will cover three things. First, I will talk about what PredictionIO is, followed by some current development efforts. We always have problems every day. And finally, I will present the future roadmap of PredictionIO that is driven by the community. So on the internet, you will be able to find a lot of material that covers PredictionIO at a high level. So this evening, I will focus more on how PredictionIO helps with bringing machine learning to production. So what is PredictionIO? Let's start with the question, why PredictionIO? When we have a use case that requires machine learning application, the natural first step is to collect data. So typically, we will continue down the path of modeling, scoring, and evaluation. We build this pipeline once and call it a day. However, how about now we need to handle a different use case? We continue this cycle again. In fact, one of PredictionIO co-founders, Simon Chen, shown here, faced the exact same problem again and again with his previous startups. So we figured there was a good pain point worth solving. When we build a system that applies machine learning in a production system, in most cases, it boils down to a set of common components: the data collection, transformation, and serving. In many cases, the data collection and serving components can be reused. Now let's answer the question, what is PredictionIO? PredictionIO is a machine learning server that aims to shorten the time from lab to production for machine learning application. PredictionIO provides the data collection and serving components, abstracts away the underlying technology of these components, and exposes an API that allows developers to focus on the transformation component. From the perspective of developers, all they need to care is how to build an engine to support their use case. Shown here as smaller circles are the engines. A PredictionIO engine is based on the DASE architecture, which stands for data, algorithm, serving, and evaluation. PredictionIO's API is designed in a way such that developers can design custom interfaces between the DASE components while providing compile time type safety. The event server, the circle at the top, which handles data collection, and the engine server that wraps around these engine circles, which provides real-time scoring, are taken care of by PredictionIO. Engines written on top of PredictionIO's API are guaranteed to work across different underlying tech stacks. The PredictionIO ecosystem also includes an engine templates gallery, which is shown here, where developers can start their work quickly by picking a template that relates closely to their use case. So in this gallery, we have engine templates that are closer to the machine learning algorithm level. We also have engine templates that are more closer to the use case, so people can say, I want lead scoring, can just go in directly to the template gallery and use lead scoring directly. So now, let me show you a quick demo of PredictionIO in action. So on my machine, I have installed the latest Apache snapshot release. So with this PIO status command, I can check that my system is all ready to go for PredictionIO. So the first step is data collection, and PredictionIO handles that with the event server. I can start it with a single command. And now I have an event server live at port 77. Let's check that. Great, it's alive. Very helpful. So next, we want to throw some data in the event server. So event server is designed to have this app concept. So you can have multiple apps sending data into event server, and you can retrieve this data by apps, app names. So data from different apps will not mix together, and you can have one event server that handles all the data collection tasks for you. So here I have 3 apps here. Let me import some data for this recommendation template. So what this Python script does is using PredictionIO Python SDK under the hood. And by using this SS key, it reads a sample data set and imports this data into event server. So this is useful when you just start tackling a machine learning problem, but in the real world, you would run event server, have this SDK running in your backend and keep sending data to the event server. So I've just imported 1,501 events. So the next step is to build this engine. Let's do this. So by typing PIO build, it builds the engine and tells PredictionIO about this engine. And it says your engine is ready for training. So let me do that. So training is simply typing PIO train in my console. In fact, under the hood, PredictionIO uses Apache Spark. So the training is handled by Apache Spark, and the input and the data output is handled by PredictionIO. So see here, I have the training completed successfully. So let's do the magic. So I'm going to run the PIO deploy command, and it's going to give me a REST API that serves predictions. So let me change to my Postman. So say I have a query. I want to retrieve recommended items for my user ID 0, and I want 4 recommendations. I can now send a query to the engine server that I have just deployed. And I got 4 recommended items. Just in case you're wondering if this is fake, I'm just going to increase the number and change the user. So great. So this is how PredictionIO handles the real-time scoring for you, and it deploys automatically to a REST API. So the next thing I will show to you another template. It's called the text classification. So PredictionIO is based on engines templates, and it doesn't only helps you with recommendation problems, it also helps you with other kind of machine learning problems. So I have just redeployed a new engine. So this query is not going to be useful for me. And say now I can type in some text here. Say fast money working from home. Is it a spam? Yes, it's obviously a spam, right? Okay, so I'm just typing something. Say, hey, I'm Donald. Hopefully this is not spam. Oh, not spam! Yay! So with PredictionIO, you can deploy these different application use cases really, really quickly. You can also download different templates from the gallery and play with it. So
in this case, you stopped the previous engine and started this one? Because both are 480, or can one handle multiple models?
okay, so the question was, did I started this new engine server on the same port? And can an engine server handle multiple models? Good question. So in fact, I can deploy with a port argument. So for convenience, if you don't specify a port argument, it will undeploy the existing engine server on the same port. So in that case, you can simply do something like a cron job. You can do PIO train and PIO deploy, and that's it. That's it for your system. So that was quick and easy to get something running. So in addition to providing a faster time to production system, PredictionIO also gives you a bunch of other goodies. I will cover these topics with little demos. So the first thing I want to cover is what is DASE. Let me reiterate. It stands for Data, Algorithm, Serving, and Evaluation. A PredictionIO engine is by definition these 4 components written in Scala. Let us take a look at the definition in Scala code. So let me just quickly show the structure. So each of these engine templates are simple SPT projects. And shown here is in engine Scala, you can see that the structure of an engine is defined inside the factory method. We can see, which glues together a data source, a data preparator, an algorithm, and a serving class. So now let's take a look at the data source. The data source component extends this P data source base class. You can see that this base class is parameterized by types. In fact, building a PredictionIO engine is all about providing implementation to these base classes. So let's take a look at the second component, which is the preparator. You can see that it also extends a base class with training data type and prepare data type. Let's move on to the third one, the algorithm. It's extending a base class with the same prepared data type. So what is good about this? Our experience with debugging data pipelines is that most of the time, it is very hard to find out what has gone wrong in the middle of a pipe if we hit a runtime error. These DASE base classes are designed to provide compile time type safety. So let's find out by changing the type parameters a bit. Say, let me change this prepared data to another class. So now obviously they are not in sync anymore. Although by the way, they are identical. Now if I go back to perform a clean build of this engine again, so clean build usually takes, okay. So this is how we provide compile time safety. If your interfaces are mismatching at the framework level, PredictionIO will prevent your engine from building successfully. So this is very important to us because with our experience supporting different customers, they always bump into this situation. Like if they use Python, it's dynamic typing, and a lot of times in the middle of the pipe, something happened and it takes just enormous amount of time to debug what's going on. So besides compile time safety, you probably noticed in engine.scala, you can provide a map of algorithms. What is good about this is that you can source and prepare your data only once, and you can train multiple algorithms at once in parallel. And at the end, when you serve it, you can define your own custom way of combining these scores. So that's it for days. Now I am going to talk about engine instance. In our quick start tutorials online, the concept of an engine instance is almost invisible, but it is very important. By definition, an engine instance is the result of training an engine with training data, engine parameters, and its environment. So in other words, it is a trained model with metadata describing how it was trained. When we do PIO deploy, we are actually deploying an engine instance, not just the engine itself. So why is it useful? Imagine you have a system that trains every day on new data, and this morning there was a data corruption at your data source. You're almost certain that your new engine instance is bad. What would you do? PredictionIO actually stores all previous engine instances for you under the hood. In fact, when you do PIO deploy, it automatically deploys the latest engine instance for you. It is possible to specify the exact engine instance to deploy. This gives you the ability to roll back to previously known good engine instances, and is a very important feature for production systems. Let me show you with a quick example. So in the text classification engine, let me train again. Notice at the end there is an engine instance ID here. So if I deploy right now, I can see that I have deployed a text classification engine instance with the same instance ID. So let's simulate a situation where you have now new data and I want to deploy it and I want to train again. So now you got a new instance here. I can deploy this. And if I refresh, I will get a new instance, right? But I know this is bad. So what do? I can deploy an actual instance that was just trained before by doing this. So now I'm back to my good old model. Next, I am going to cover engine variance. I hope by now you are not tired by a bunch of engine whatever terminology. So fortunately, this is gonna be the last engine concept that I'm going to cover.
So what?
Sure.
So in that case, let's say day plus one's data is bad. Now day plus two, we want to train with day plus two's data, but skip day plus one's data. Because day plus one's data was bad, it resulted in a bad engine. So what do you have to do in that case? Do you have to explicitly code for it, or?
So if I understand the question correctly, you are saying you want the next training to exclude the bad data automatically? So
Code for that, or something you have to kind of code?
So right now, PredictionIO does not support that. So in case you have a data corruption, the best thing PredictionIO can provide you is to roll back to the previous model. So you have time to go in to look at what data is bad. and you can actually have a data source that supports blacklisting certain date period of data. So you can implement that at data source as well.
So is it hitting Spark for the scoring, or is it, implementing something like PMML or something?
Okay, so if I go back,
PIO.
yes. So if I go back to serving, so PredictionIO actually supports two modes. So in this mode, a model can be what we call it local or parallelized. So for a local model, it's a model that one single PL engine server can load into memory. So the scoring will be done on that server in real time. But if you have a use case that have a model that spans multiple gigabytes, PredictionIO also supports scoring against RDD or data frames.
But is this model something that you've binarized and persisted in Spark, or is it just like a live instance of the model object that you are keeping alive inside Spark?
Oh, it's actually configurable. So you can persist it locally on disk,
Okay.
on HDFS, on the JDBC database, anywhere you like.
Okay, cool.
So it actually highlights what PredictionIO does for you, right? You can have multiple tech stack configurations, but engine developers will only need to write against one single API. And the engine developer does not need to worry about all these configuring different data backends. Cool. So let me cover engine variance. So it is a very helpful tool if you need to do experiments with the same engine, but different training inputs or parameters. So recall how an engine instance is produced. A new engine variant in this picture would mean using an alternative set of input and environments for engine training. So it would be easier to understand with a little hands-on example again. So by default, each engine has a default variant. It has an ID default and have some algorithm parameters. It can have some data source parameters. Whether these parameters are here are up to the engine developer. But if we say we want to test with a different lambda value, we can duplicate this file, say engine2.json, and I put a lambda value of 0.05 here. And going back to the example, actually, because of the previous demo, I will need to go back to make building engine works again. So pardon me, but let me rebuild this engine. Great. So now I want to use a different engine variant for my training. I can simply do a -v and put in the new JSON file. Now when I deploy, I can just do this same thing. Just replace train with deploy. Let's reload this. Now I can see I've deployed an engine variant ID v2. So why is this useful? You can train and deploy different engine variant instances on different ports. So you can perform experiments, A/B testing, or whatever test that you want to do. So these three features highlight what PredictionIO helps you in a production system. So let me talk about the current development. At the moment, we are working very hard towards our first Apache release, which will be version 0.10.0. We have been busy migrating to Apache infrastructure. Git repos, websites, documentations, and releases will all be on Apache infrastructure. One great thing about the Apache donation is that we are bringing back all the diverged forks of PredictionIO back together. Forks are now converging, and we are merging in a lot of great and useful features, such as installer fixes, and we have a new sliding window event data source that will automatically clean up old data with a specified time frame period. Engine templates and SDKs are also being migrated, and we are planning to have every new PredictionIO release tested against a fixed set of templates and SDKs. This should make PredictionIO ecosystem a lot more stable than before and give a clear indication of what is compatible with what. Finally, a couple weeks ago, we introduced a Docker-based integration test infrastructure. It supports PredictionIO and its engines to test against different stacks. So the setup is based on Travis. It runs all these tests in parallel. One of them runs the normal unit tests, and the rest of them are integration tests. The interesting part here is that to provide different environments on Travis, we have built a configurable Docker container image. When Travis starts a new integration test, it will first build a PredictionIO distribution, injects this distribution together with test code to the Docker container. Travis will then start these different Docker containers in parallel with different configurations. So this is extremely valuable as it allows us to scale out our tests to cover many different situations, because we interfaces with so many third-party software. It is very important that we guarantee engine templates can work across these different vendors. In the near future, we planned to cross-build against both Spark 1.x and Spark 2.x for backward compatibility. Data native support of latest Spark features is also high in priority. Multi-engine serving is one of the most requested features, and it is in discussion. If you have noticed from the previous demo, each engine instance is deployed with one JVM on one port. Suppose you have a bunch of smaller engines, and you need to deploy all of them on separate JVMs and ports. That would be pretty wasteful, right? So multi-engine serving will allow you to deploy more than one engine instance on a single JVM and port. This will help save resources and make hosting multiple engines or tenants easier. A couple days ago, we have received a contribution for CLI refactoring. It paves way to build a more full-featured admin API. This admin API is very important if you want to programmatically control PredictionIO operations, such as creating new apps that I've shown on the CLI, access keys, managing all these engine variants and instances, and rolling back engine instances as well. We are thinking about how we could provide testing for contributed engine templates by leveraging the integration testing infrastructure that I've just demonstrated. So we are hoping to provide something like Travis for engine templates. And in the further future, we are considering making PredictionIO more composable, in the sense that engine developers can break away from defining a waterfall style DASE components and compose it more like a Spark ML pipelines. So we have many work to do ahead, and we need your help. Please subscribe to our mailing list, and feel free to talk to any of us. Please join forces with us. Thank you so much for listening.
We can take some questions, and we have actually a mic we can pass around if you're interested in asking a question.
This is a great contraption. I'm going to throw it to you guys.
Ready to catch it? It's on, huh?
Hello.
I need to walk to you.
No, it's on. It's a mic.
Oh, it's
You
on
got
this
it.
thing. Okay. Two questions. Looked like you were using actors for some of the concurrency stuff under the hood. Using Spray, Akka, HTTP. You chose one or the other. Why'd you choose it? The second question is deployment. If using a container orchestration framework like Docker Swarm or Kubernetes or Mesos Marathon, is there some integration integration work in your roadmap for PredictionIO?
Yes. So for the Spray choice, the code base actually started in 2014, and I know Spray, it's kind of Akka HTTP kind of replaces Spray now. So when we migrate to Spark 2.0, we are planning to replace Spray with Akka HTTP. So there wasn't like a novel decision of picking between SprayCan and Akka HTTP. It was just a historical thing. Regarding the roadmap about integrating with Docker Swarm, yes, we have it on roadmap, and I think actually one of the merging forks will bring in Docker integration. So you would be able to deploy event servers as Docker containers. You will also be able to deploy engine instances as Docker containers.
Hello.
Got a question back here?
My first question is, do you have support for Node.js? And second question is, are there any real-time use cases that has implemented PredictionIO?
Yes. So for Node.js, do you mean like a client SDKs for the event server? Yes, I believe there's a community contributed Node.js SDKs on NPM. And for real-time cases, we do have some clients before that use PredictionIO to say like track what people are reading on their news website, and then in real time do some retraining and recommend them some more recent news articles.
Anybody else? This is your chance to use this great contraption. Here you go.
Touchdown. Okay, that's 6 points. So what does PredictionIO do to help me meet my SLAs in terms of responsiveness on the web front-end side?
It's a good question. So PredictionIO does not actually provide something like this. When we first designed it, we want it to be providing an experience that is as similar to something like Django or Ruby on Rails. So we are definitely missing on that side, but if you have any good ideas, feel free to talk to us. We are happy to add those to support your use case.
Okay, you can use this one.
Hey, there you go. Hey, Donald. Question about Salesforce Einstein, the new platform that was recently announced. Does PredictionIO have any role in that? Are you guys going to contribute to Salesforce Einstein, the new AI platform?
I have expected that question. So I believe our CEO just announced it 2 days ago, and I am not in a very good position to talk anything about Einstein, so I'm sorry that I gave you a bummer, but go to Dreamforce. We'll be there and we will announce things.
Any more? Going once? Twice? Oh yeah, brilliant.
Earlier you showed that you can embed algorithms in a map in the engine, but those algorithms, have they to be the ones that only Spark can support, or they can be any custom algorithm that you have developed?
It can be anything. It does not have to be limited to Spark.
Anybody else? Okay guys, give a big hand to Donald.